Thank you for joining us. You're watching a career success video from Computer Coach. Computer Coach is a Tampa-based computer training center specializing in helping IT and business professionals add on the skills they need to reach their desired career goals. If you are job searching, in transition, or are looking for guidance, please feel free to reach out to us at www.computercoach.com. Now, let's get started.
All right. Good morning, everyone. I too am excited for the topic today. So thanks for joining. My name is Danielle Ori. I am the Director of Career Services here at Computer Coach. We are a tech-based training school in Tampa Bay, Florida, sunny Tampa Bay, Florida. And we offer full-time and part-time live online classes in the areas of coding, cybersecurity, infrastructure, data, and then a variety of business topics such as business analysis, project management, and digital marketing. And if you were to choose Computer Coach as your training partner, you're going to be joining a community of passionate learners and industry experts who are committed to your success. Whether you are looking to become an IT professional, a career changer, or looking to upskill and enhance your career, Computer Coach is here to support you. And without further ado, I would like to welcome our wonderful guest speaker, Aman Sharma, who's going to be talking about unraveling large language models. So I'm going to turn it over to him. Before I do that, I want to remind you to please use our Q&A feature to add your specific questions, which we will address at the end. All right, take it away, Aman.
Thank you so much, Danielle. I think it was 4 or 5 months ago when you first reached out and wanted to do a session. And while back then I didn't knew a lot about LLMs, but I usually have this fake it till you make it kind of personality. Like even if I don't understand anything, I'll commit to something. And by the time I am on the delivery time, I'll with some luck and some hard work and some more hustle, I can reach to that point where I can understand the topic enough that I can explain to other people, or now potentially even build a complete new startup and a platform on it. So I think 2 days ago, I asked you to change the company name from Dinify to Lamatic, and that's how fast all these pivots really happen in this industry. And that's what basically what the title of the talk that we are today going to discuss about also is. It's like unraveling large language models, how to build apps with LLMs. It's kind of a subtopic, but it's very important to understand the predecessors to how this LLMs came into being. Like what is all this fuss about? Obviously, there is a lot of fad going on. There is like a lot of bubble about what Gen AI can do and what it can't. So I'm gonna settle all the dust today, and hopefully by the end of this presentation, you guys, I don't expect you to start building LLM model yourself or build full Gen AI powered applications, but at least something that you can do your own due diligence, check out different solutions, think about what LLMs can do, and potentially add them to your own business, whether it is about automating stuff or even using it for your own personal use. So let's drive straight into it and let me see. Okay, it works. Okay. So my name is Aman Sharma. I've been a serial tech entrepreneur. I've been lucky to work on really amazing products. So before founding Lamatic, I have done 3 other SaaS companies, Atlance, Key Events, and Twimbit. And the last one was the really kind of the turning point in my life where we combinedly all these products and the company that I worked at have reached over 1 million plus users. And I usually focus more on the application side of how to build AI-based applications. My field of study for the last 7 years has been around NLP, large language models, recommendation systems. Before all this was really cool. So we used to just work on standard statistical model, and then people started calling it AI and machine learning and that sort of stuff. So I've deployed a couple of projects online. Some of them failed, some of them did worked out, and I sort of condense all my learning in this weekly newsletter that I write called as Build and Scale Fast. I have shared the link with Danielle, so she'll share it with you about subscribing to the newsletter. So currently I am a co-founder and CTO at Lamatic, which is end-to-end Gen AI integration platform that helps people launch Gen AI products and applications really, really fast and really, really reliably without having too many technical people you need to hire to build such solutions. I also head the AI and data team at 84,000, which is a worldwide initiative to preserve Buddhism. It's a non-profit, and it helps in preserving the Buddhist literature and converting Tibetan to English. So we are using a lot of AI and large language models over there as well. to make sure we preserve the ancient language. These are my socials. Feel free to connect. I am always open for brainstorming, validation, startup advice, geeking out on new cool technologies and stuff like that. So feel free to reach out. Okay, so the agenda of what we are going to discuss about today is we're going to start with understanding this whole Gen AI fad, like how it came into being, what is the AI evolution. Some of this you might already know, but some of this might be new to you. So that's a helpful transition for us to get into then what really Gen AI is. And then this building block of Gen AI application, which we usually call agents or assistants, more popularly called agents these days. And then what comprises of a good agent and how to build your own agent. And then finally, some cool demos, some products that we have been able to build with these agents. All right. And I will keep the question room open. And Daniel, please feel free to interrupt me if anybody asks any questions. I want this to be really interactive. So as soon as somebody asks it, I want to wait. I will take some pauses during the presentation as well. And I would want the audience to engage as much as possible because this is a learning experience for me as well, trying to learn what people have curiosity about like Gen AI and what needs to be simplified. So really appreciate like your interaction throughout the webinar. Awesome. So let's start with the trillion, or I don't know what comes after $1 trillion question, that what is Gen AI, right? And I want all the wrong answers that you can think. I don't want a general explanation. Gen AI is something that generates text, right? So let's see the chat room and let's see who comes with the most bizarre creative explanation of Gen AI. I'm gonna open up the chat room so that I can like look into that as well. Job stealer.
Of course, I'm just kidding.
No, it is maybe for some people.
Feel free to also come off mute if that's easier, if you can Skynet. Yeah, the
generative stuff. I'm gonna take 5 more creative answers. Pathway to artificial general intelligence, AGI. Oh my God. Assistant today, boss tomorrow. What comes after Gen X? Oh wow. So evolution of mankind. Okay. Lever to raise capital. Yeah, that's my co-founder, by the way. Don't mind if any of our investors are also joining this. Awesome. So yeah, I mean, cool answers. I really like this sort of methodological thinking of like what else Gen AI can do other than somebody just trying to sell you a cool idea, like, because I think the criticism in technology is really important to really build safeguards and guardrails around like how tech should work. And I'm like sometimes also the victim of being too dreamy or utopian about how this technology will come out and stop caring about, what problems a technology solves and start getting into, hey, it can do this, it can do all this wishy-washy vaporware. So it's very important to ground yourself and see Gen AI as just an evolution of software development. Like that's what I called Gen AI. So that's a great note for us to like jump into something really interesting is the evolution of AI, like history of AI. Before pre-Gen AI, how does this all started? So it's almost 1940, 1950s, like 77 decades ago. We had the foundation of AI, where Alan Turing laid down the foundation of Turing test, which is basically a test that differentiates between what is a human level intelligence or what is just a normal computer algorithm. So he created some test and then he called it Turing test. And that was the foundation of AI. There were like no actual practical use over there, but there was artificial neurons that they built in some, basic assembly level code that can actually take input and they can classify things. So there were like general abstracted principles like number identifications and text identifications on OCR format, but nothing really like came upon in this era. Then the era of machine learning really came, right? Like there were early developments of this tool called as ELIZA. I have been fortunate, like when I was like very young in my, I think 7th standard, I interacted with the system. Somehow it ended up on school's computer and I chatted with this. It was a very rule-based AI. So I wouldn't call it really AI. It's just a rule-based answer generating machine at that time. But I was really fascinated. I could see that, okay, this can get smarter and we could be at a point where we can have AI personal assistants we can talk to, they can answer and stuff like that. Google was really popular at that time, but I always thought like there could be a much better way to interact with these systems. And for those of you who haven't tried ELIZA, It's kind of a pre-chat GPT CLI version of things. It's really dumb. It answers the same things if you keep asking the same question. So it's not as smart as chat GPT, but it showed the glimpse into like how these things can evolve. Then in 1980s, there was really nothing much happening in the AI field. Nobody was even paying attention to neural networks, backprops, and all these things that were going in the machine learning. Everybody thought like, because one primary reason was that there was not enough compute. So all the machine learning engineers or people in this field were always hitting sort of a ceiling of what they can do with the AI systems, right? But with 1980, we all know like Intel came along with its Moore's law, and then there were more and more chips happening, and that's where we actually were able to build functional neural nets. And by 1990s, we can have early like a deep learning system. So deep learning system are basically convolutional neural nets, and we'll talk a little bit more about these things as well. And they are able to beat the famous Gary Kasparov versus a chess AI bot, which was able to beat. And then that could be said like the first wave of when we saw, okay, neural nets could be a great thing. And then one of the sort of founding fathers of modern AI, I don't know a lot of people know him or not, it's Geoffrey Hinton, Sir Geoffrey Hinton. That's how he's mentioned. And I think he's now retired. He left Google, but he was with Google all the time, and he was sort of the foundational pillar of like the Google AI initiative, and he was like the father of modern generative AI or neural net based AI. He came up with a lot of technologies around deep learning and how we can have backprops, how we can have convolutional neural nets with different layers. A lot of that went into creation of frameworks like TensorFlow. There were other people involved as well, Jeff Dean and all, and then they have gone separate ways, creating their own independent startup. So that's a similar kind of background, like PayPal mafia, that might have happened, which lands us to this new era of generative AI. So kind of interesting thing. A fun fact about Jeff Hinton is like, I think almost 6-7 years ago, he had an injury in his back, and he hasn't sat ever since. He can't like sleep. He always stands straight. It's a kind of a miracle thing, like a guy who has built so many things for us. He goes through his own pain, but he's such a important person for the evolution of Gen AI. So that's something, a cool fun fact. I wouldn't call it a fun fact, but a fact that I know about Sir Geoffrey Hinton. And I think we should all be very thankful for like this guy. If it wasn't for this guy, everybody was like, neural nets are not going to work, but this guy always kept his like calm and kept on in his work. And now we see how neural nets can be really important, and they can replicate the human brains, how the human brains thinks. And that's what is the evolution to Gen AI. And then we land up to today, which is the rise of AI. Like, everybody's talking about it. IBM Watson beats the best quiz master in the quiz competition. Like, it's able to use these generative jams, which is neural nets again. And they are like, similar working as how human brains functions, right? Like, you don't need to create rules for something. You can create these neural nets, which are artificial brain kind of patterns, and then it can figure out what the information is without much training. It just understands the pattern. It learns the way like a human do. And that's the same point where we have OpenAI. And in 2020, you can see that we have wave of all these products coming around like GPT-3, DALL-E, GPT-4, Google Bard. And like, this is the current news, and we are all aware about that. But I just wanted to like take you through this brief history of like where we are really coming from and how the divergence really happened. So if we have to like summarize in the nutshell, the chronology of how basically the different layers of AI systems have been evolved is like AI is the whole big shell, right? That's like the whole subject matter, right? Inside that, we have a field machine learning, right? And in machine learning, you can have supervised machine learning, you can have unsupervised machine learning. And by the way, it's kind of a muddy, blurry definition on what you call an AI or not. Like, even though I have said numerous times I work on AI and all, but sometimes when you get into the grooves of things, like you can't really differentiate if something is a rule-based system or an AI, like something that automatically lands a plane. Would you call that an AI as well? So there is like a very blurry line between what classifies as an AI or not. But ultimately, like anything that can replicate human intelligence in some format and learns on its own is, I would say, can classify as an AI. And apart from machine learning, there are other subject matter expertise in AI as well, how you can basically do this thing, right? So you have recommendation system. That's also a little bit of machine learning, but doesn't involve the same principles of supervised and unsupervised machine learning. Then inside the machine learning, there are other different approaches as well. But one popular one is deep learning. And deep learning is basically when you use these convolutional neural nets in different layers, and each layer sort of learns and understands a concept, abstract principles about a problem. When you pass the solution and the question so many times that the layers automatically sort of develops a plasticity in the neural networks and like how our brain really functions. So that's where the deep layer learning is really good at. And there is a popular algorithm we call it backpropagation. So it's like a shortest path finder between one point to another. It's in a similar context. What we do is like we give a question and we give a solution as a training. And then we give so many examples, thousands and thousands of examples, so that the AI sort of develops its own pattern. It doesn't know if it is really, for example, I show Apple 1,000 different times and say this is Apple. It really doesn't know like what really an apple is, but it identifies characteristics. It breaks down the image into such way that it is able to now classify another object as well. So it really is dependent upon like human labeled data sets and stuff. And then we have these neural nets, which are like the building blocks of all these systems, right? These are like synthetic human neurons, sort of, you can say, that are into computer systems. And the processor are the chips, the GPUs are the way that these neural nets are actually being executed and trained both in these systems, right? And it's from this neural nets where we get the LLM, large language models. So why large? Because it is trained on terabytes of text, 10,000 terabytes of text. Like it's unimaginable like how much information this really is. But that's like the main cost of tuning these LLMs. Like how I explained you, like if you have 1,000 examples of Apple, then a neural network learns what an apple is. And imagine giving it 10 terabytes of text, and then it can classify, what text is and what the meaning of the text is. And you combine this data with 6,000 GPU for 12 days, which is roughly $2 million in price. That is what gives you this 140 GB zip file, which we call parameters. This is what foundationally LLM training really means. This is foundational training. And just to give you a scale of things, ChatGPT has done the same process over like 6 months for ChatGPT 4, and they have used, I think, at least 100,000 GPUs. So you can multiply the scale. It's almost a $2 billion investment of compute to get ChatGPT 4 parameters, one zip file. And once you have this zip file, you can use any system. You can use your laptop that you are using right now to execute the LLM model. So what you see in ChatGPT once the LLM model is trained and what you're interacting with, that is not a very compute intensive thing. So that is why the tokens are really just a way to identify how much a person is consuming, but that's not really resource intensive. Creating this parameter file is what the LLM training means. And this also creates a huge barrier to entry because you need humongous amount of resources. So as a startup, if you're thinking you can build your own LLM, forget about it. So what usually we rely on is like we rely on a lot of open source large language models, right? Why it's a good idea to do this with open source large language models is because we can use them as foundational large language models and make it purpose driven for our own specific task. We'll get into those details, like how you can use foundational model and how that transition into a fine-tuned model. But I just wanted to give you a scale of what these large language models means and why there are only few companies that are able to achieve this, because it's just like non-feasible commodity for a lot of businesses. And the important thing also, a turn of events, is that the GPUs, the same GPUs that are really good at rendering video games, rendering graphics, are also really good at doing the most important thing that the training really needs is a matrix factorization. That is how fast you can multiply rows and columns. It's just a simple thing. And since GPUs operate on a parallel architecture rather than CPU, which is a linear or a serial architecture, they are able to do it. It's just a simple coincidence that what powers the game can also train the parameters at the same time. And thanks to that, NVIDIA has its own boom right now, which is like trading on off the charts, right? Okay, I'm going to take a pause here. Feel free to add your comments and thoughts. What's going on in your head? Any questions?
No Q&A yet.
Okay, cool. Awesome. Feel free to like ask your questions. I'm trying to create a buffer, and then I'm going to take these pauses to like go through your questions and then, answer anything I can. I think there are a few people in the waiting room as well. Okay, awesome. Okay, now the interesting thing is like what I was explaining before is that this whole training things gives us these parameters. So what are these parameters really for? So essentially, parameters are for these neural nets. So imagine like neural nets as pipe drains, like those magic pinball games that we play in different scenarios, right? It depending upon how the ball flows from different patterns, it ends up in the final sort of the hole, and the way it takes the part decides like what that really thing is. So in really a high level abstraction, neural nets are nothing but a pattern graph where when we pass certain information, it turns on and off all these neurons, it activates these neurons at a certain intensity. And combining all these neurons is what gives us the final answer. Now, these parameters that we learned before, which is a 140 GB kind of file, which took all this time and all these compute resources, are just the weights for these neurons. These are sort of minor calibration, like how big these pipes are, how the data flows. So when I pass a word like cat, what pathway it takes. That parameter file that we have generated from all this training is just a small sort of condensed thing. Think of it as like the same compression we do over with files as well. So we compress all the knowledge that is existing out in the world, or whatever you train this LLM on, and we compress this into one neural network. And that is what helps us predict the next word sequence. And this is the most important foundational pillar for GenAI. Predicting just the next word is the most important problem that GenAI solves. And that's where we have the GPT. There were a lot of neural net based word predictors. We had BARD, we had like Google's initiative on other things as well. We had natural language generation, natural language processing for almost 2 decades, but none of those techniques were working, right? Like if you had two examples of the same word, it didn't work really fine. It would create very artificial looking sentences. So what really changed in the chat GPT 3.5 era? It's this architecture, which we call GPT. Generative pre-trained transformer. Generative because it can generate text. Pre-trained because it is pre-trained on a lot of information and a lot of parameters. And transformers, which is the most important thing, which is like it encodes and decodes the information through large neural nets, and that's what gives us the final result. Now, how does it works? Well, nobody really knows. Like, so what we are really doing is we are just inferencing with these systems, right? We pass one thing at one time, we train these neural nets. So the most important paper that came upon like almost 4 years ago is the attention is all you need, is this self-attention mechanism. So previously what used to happen is like when we were predicting the next word, cat sat on a mat, we were just kind of building predictability, like probability of what the next word could be. So it would just look at the last word and the sequence of the word that would combine that. Now, this approach is not really good. So let's say if you have a word that comprehends to the whole sentence, then it won't really work. That's where the self-attention layer was involved. So what self-attention really means, if you can see in this diagram, is that we are going to pass that sentence again and again through that neural network. And then at some point, we will have one single column that has the extracted principle and a sort of a relative meaning of each word in respect to each other in one single array. It's very hard to comprehend, but that single thing changed everything. So now you can have one vector array we call vectors, which are sort of sign language for large language models, and like kind of understand that as ASCII value a is equal to 26 or something like that. So we convert each word which has its own vector dimension, and then we do this whole transformer model to obtain the last element. And we actually don't even know if the LLM themselves understand like what's going on, but this is a technique that works, and the next text that we are predicting is significantly better than the previous approaches that we have done. So what we really know is that the more parameters that we add, so the more information we train it on, all the training that we did in the previous steps, that is one thing that really helps the model to become smarter. So how in ChatGPT 3.5, we had 2 billion parameters. In ChatGPT 4, we have 7 billion parameters. Now there are 70 billion parameters. Who knows like how many parameters GPT-5 will have? So that is a really important thing that improves the quality of these large language models. And then another thing that really improves the quality of these responses is fine tuning. Like remember, ultimately everything is about generating and prompting the next word, the next best guess for that word. So how you give the prompt, the initial statement to these large language models or generative models decides how they are going to end up generating the response. So most of the research and most of the application field, what they are doing is just playing with these prompts, and that's where we land with this prompt engineering thing. So you guys has probably like seen this example a lot of times. So what we really end up doing is that we have training the assistant kind of system in which we have a user dialogue, and then we have an assistant dialogue, and then we kind of expect the LLM model to continue on the sentence. So a prompt is just the initiator of the sentence, and then we just ask it to continue improving on the sentence. And when we say about fine tuning, it really means that we are giving a lot of examples to the LLM so that it sort of develops a sense of how sentence completion really works. So what ChatGPT 3.5 and 4 did was that they generated all these parameters and all these neural net weight dimensions, and after that they trained it on a very high quality information. So when it says that the cutoff knowledge date for ChatGPT 4 is January 2024 or whatever, that means that the fine-tuned information that we put on these LLMs was on that time. So that is a very bad precursor, because like if you want LLM to know up-to-date facts, it won't know that. If you want it to know what is right or wrong, it won't know that, because it's just a next word predictor. But what you can do is like you can create guardrails and prompts in such a way that it has less tendency to what we call hallucinates, like its tendency to go off the guard and say blurb things that doesn't really mean anything. All right, so what really involves, if we just recap what happens with all these big companies, that every year they come up with a new pre-training, which is the first stage, which gives us the base model. You compress 10 terabytes of text, give it 6,000 GPU, and compress that into one single neural network layer. And that's a very expensive process. As we discussed, it's $2 million. It takes 12 days to compute and all that. This is usually done only once in a year, or like depending upon how much funding or how much new money a company is ready to throw at it. So that's why we see the frequency of ChatGPT 3.5 and then 4, 5 almost once a year. So that is the base model. Then you have fine tuning, which user can do it themselves. They can label the information, they can create new prompts, they can apply approaches like RAG and all that kind of stuff. So these are the two different layers in which all the LLM based activity is really based on. I'm gonna see if there is any questions. All right, so far so good. Are there any questions or?
Nope, not yet. Just one person in the waiting room.
Okay.
Cool. I'm adding them now.
Right. Now, what is changing from you have all these LLM models. There is nothing much changing in the architecture of these GPTs, right? What we discussed before. But what is really improving in the way we are able to make these LLM more accurate and more kind of less hallucinate and have more guardrails is these tree of thoughts. If we can give the capability to the LLM to think by itself through chain of commands, like how we as human things, it's sort of an inherent nature to us that we can just break down a problem into multiple tasks and then think through it. So what we figured out is like if we do this chain of thoughts, COT, through prompting, so do this and then get the output and do this, these models can actually work way better than their natural format, which is just generate one single text. So from A, we go into chain of thoughts, and then we go into self-consistency chain of thoughts, which is when OpenAI gives you two responses for the same question, so it's comparing through that. But there is tree of thought as well, where it is making multiple decisions, and based on how each decision ends up being, the quality of that response decides what the final output is going to be. And that is the game changer in the industry. So when you want to implement LLM, it's all about how you can break down your problem into smaller and smaller problems, and then how you can have a more accurate answer. So all the company out in the world which claim to be Gen AI companies, Copy AI, Daily AI, and other Gen AI companies, what they are doing is that they are breaking down the problem into series of prompts and providing it very accurate information to have more accurate response and answers. So that is the differentiation between anything that is out of ChatGPT's mouth or how you can break down the task into your own company's backend. So we have one question. I'm going to see how and from where are data being sourced by companies to include in there? That's a really great question. So there are a lot of deals made behind the doors between ChatGPT and other big companies. So for example, Reddit was a very, I think, big contributor into ChatGPT's data source. Again, there is like no clear information on like, what information was used. So that is sort of a reason why people are now going towards the open source model instead of the closed source private models like ChatGPT, because they don't really disclose what information they are training on. But it can include vast array of information. It could include all the Wikipedia documents that exist. It can include all the Reddit conversation that exist. So for example, Grok is trained on the XAI Twitter, like a chatbot is based on all the conversation that is done on Twitter. Google is using a lot of Google search results. So there are like a lot of different approaches you can do that. And one of the primary factors to improve the parameter quality is based on what data source you choose. So it could be paid private data sources as well. They can include research papers as well. So, they are going through all these heaps and loops of finding all the quality text that's possible. So one of the most important thing that you do before pre-training is also, selecting what information sources you have. Because if you put garbage in, you will have garbage out. So that's what was found. So let's say like it's sort of an inherent nature, and I think it's in human nature as well. Like whatever the child learns from their environment is what it becomes. So let's say if you would give a lot of political arguments and all that as a training information to a LLM model, that's how the response is going to be. That would be the personality of the AI. But if you give it like a personality, like a coder and all, that's what it will give you GitHub Copilot. So it's sort of a self-learning model in which the data that you provide is what the nature of this LLM is going to end up being. And then tree of thoughts is another thing, like how LLMs really think and break down these problems. Okay, based on this tree of thoughts, like I'm going to go a little bit back and see how this pattern is really emerging. So we have the LLMs where we train them, get these parameters, which are just a next word predictor. Then we write a very nice starting text for the LLM, and then it completes the sentence. Now, the second principle we learned is like we can break down these series of sentences into multiple chain of thoughts to make more accurate responses. I'm gonna see this QA. Is tree of thought the same as beam search? I won't really know. So tree of thought, I don't think it's really like a search. What it is really doing is that, so let's say if I ask ChatGPT a question, for example, how do I create a presentation, right? So instead of directly giving me one answer, it is breaking down the problem. The first thing I will ask ChatGPT in the prompt system to do is understand the problem and break it down into multiple tasks. So this would be my first chain of thought, I would say, the first layer in the chain of thought. Then the second would be go through each task and generate text for it. Then the third would be from each of these texts, identify action items and create action item for it. So what we are doing is that we are giving multiple diversity to each task in tree of thoughts, and giving multiple decision making that a LLM can make, and then finding the best answer that is possible through this tree. Instead of just asking ChatGPT, hey ChatGPT, generate me a LinkedIn post like that. Right? So that's basically the difference, because we have seen that if you use that approach, it ends up giving us a very synthetic looking answer. And if you post it on your LinkedIn, anybody can spot it. It's not the right way. But a person who is a very professional sort of ChatGPT prompt engineer, these prompt engineers are basically the people that they are sort of interrogating these LLM models, since we don't know how they actually work. They're just like trying different techniques, what works and what not. They're basically doing this inferencing. And one inference that has really worked is like if we ask LLM to break down the task into multiple levels, then they are more accurate at giving answers. So tree of thoughts is not really a search. It's more like dividing the task and conquering it. Now, from tree of thoughts, what we can do is that if we can break down task into really specialized skill set, we can have something we called agents. And this is where things start becoming really interesting. So we started from a prompt. We started with breaking down the prompt into multiple prompts. We then saw like how you can chain these prompts into a tree of thoughts, and then these tree of thoughts can become an independent expert to solve a particular task. And we can have these things called as agents. And you can have multiple types of agent. You can have a math problem solving agent, which you can see in the screen as well. So you can have a student, which is an agent that just tries to solve the problem first. Then you have the assistant, where you use the LLM to actually execute and come up with an answer. And then you have another expert that is just there to assess it. So if you have specialized thing that you give to each prompt, and they parallelly go and do their operation and sort of converse with each other, then they tend to also perform the task really better. So that is what the agent-driven model comes to us. You can have a retrieval augmented chat, which is a very popular way of training LLMs on your own task. So what we do is that we use vector database to train all our data and convert that into vectors. Then we use semantic search, which is similar to full text search, but it more relies on the semantic meaning of the sentences. And then we ask our chatbot to look into this information, get the answers, and then responds back. So this is a retrieval augmented chat. You can have things like a conversational chess bot. So you have three different agents, which you can see in this example. You have the chessboard where you're running the game. You have human player, which is the A, and you have the AI human player, which is the B. And they all are sort of communicating with each other through API calls or whatever architecture you want to use. And they are solving the whole task by themselves. The only thing they need is time. So the more time you give it to them, they solve the problem, they get back to you, and they have solved all these complex tasks. And you can give them all this series of things. This is what all the companies are trying to do. They are trying to actually build swarm of agents in their backend, wrapping them into a SaaS application and calling it, we are a Gen AI company. And it is working because, these things tend to perform more accurate and solve tasks much more efficient than a human counterpart, traditional AI, standard AI model alone. Right? Now we get into what really causes these agents to work. So I'm gonna, again, if you have been following along the whole evolution, you might already understand it, but I'm going to break down the architecture of agent one more time, right? So what an agent really do is that I give it a question. It converts that question into inputs, which is basically converting them into vectors. Again, vectors are symbolic representation of an information in a vector data space using some embeddings. Then these vectors go into what we call the brain, where it can use different approaches like RAG or use its own context memory, divide the whole problem, use a chain of thoughts to divide and conquer, and then get back with an answer. And then you can take an action on it. You can convert those vectors back into text. You can also call different APIs to do different kind of API calls, or you can run, LLMs or something for a robot, like what we see with the Figure AI or other NVIDIA AI that bots that are coming. It's all based upon like what tools you give to your LLM is what they perform. So this is abstracted layer of what they do, and then it can give an answer back to you that, okay, this is the weather, what looks like, this is the website that I have found it on, like, using some API, and then based on this, you will need an umbrella, and I can hand over an umbrella to you. So this is a complex architecture of what an agent could be. And this is what, as a person who wants to apply Gen AI into your company, you have to do. Like, you have to figure out all these different parts of your business and how you can break down a problem into these three parts. So now let's look at how to make your own agent. What makes an Gen AI agent, basically? Any other questions so far?
Yes, we do have a question. I don't think it's gotten into the Q&A yet, but chatbots and Gen AI chatbots, are they the same or different? And then Gen AI use LLMs.
Yes, so two questions. Chatbots could be Gen AI, could be non-Gen AI. There are other models as well, which I explained. GPT is not the only, Chat GPTs or GPTs overall is not the only way to generate text. You can generate text with Bard model, Palm 2 models, and other models as well. It's just GPT as a technique really works well. And Chat GPT is like the success outcome of one of that, a decision. And there could be a simple, most of the chatbot that you really see, even the IVRs that you call to connect you to some human, they are going through a decision tree, and they are just relying on simple neural nets instead of using all this LLM, because sometimes these LLM can also be overkill for your application. If you have certain 10 different steps to go through, there is like no need to actually build an LLM for that. It's only when you have out of bound information, you need a human understanding to convert into something. That's where the LLM chat GPT agents are really helpful. Then I think the second question was, Gen AI uses LLMs. Yes. So that is one pattern. Like, LLMs is, I won't say is like the architecture for an application. It's just a generic name we give, which is large language models. We train large because it's a large corpus of information, language because it uses language as a way to understand context, and models because it's the AI model. That's why we are calling it large language models. But if you're using it in some other domain, Gen AI can also be used in image generation. Then you have image models, stable diffusion, and other models. If you are using it for audio, then you have audio diffusion models and other models. So Gen AI is the whole concept. And if you are using Gen AI to generate text, then most likely you are using large language models. Does that answers the question? is agents is nothing but combination of different interactions. Good question. It's a combination of everything, right? Like you have different interactions with different AI systems itself, different ChatGPT system itself. It is a composition of different prompts. It is sort of injection of your own custom data. So you combine all these approaches, and that's what we are going to learn right now as well. What are the different kind of agents you can make depending upon your use case. But see agent right now as a building blocks of your intelligent Gen AI software, right? And then you are breaking down your problem into different parts, and then that is creating agent. And we'll see like how you can build your own agent in just next couple of steps. Okay, what makes an Gen AI agent? This is going to be a really high level overview. Some of these things we have already discussed to just like go through it and understand. So the first thing agent really needs is its model, or in general terms, large language models. So you can decide models based on different types of use case. You want to generate images, video, text, audio. Based on that, you can decide a different model. You can decide based on your budget. Some Gen AI agents or LLM models are more expensive than others. So based on your cost versus quality comparison, you can decide whether you want to go with ChatGPT 3.5 or 4, which is just a difference between quality and more expensive and less expensive. So based on your own thing. You might also consider whether you want to go with the open source LLM model or a closed source LLM model. So for example, ChatGPT is a closed source LLM model, but Llama 2 is an open source model, and the Mixtral is an open source model. And what you can do with open source model is that you can copy the model, host it on your own machine. So there is literally no connection with the outside internet, and there is no way ChatGPT or other model which you are sending information to can use your private information. So these are really good upcoming use cases of self-hosting LLM models into your own containers, and they usually perform the same way sometimes in ChatGPT. And if your use case is not that trivial, then you can probably use open source models. So it depends upon your use case. And the last parameter is the quality. There are different types of benchmark which are used to identify which LLM model is the best, and these are sort of race horses between different things. And again, what we discussed before, the more GPU you give to them, the more quality input you give to them, the better they get. So based on all these things, these all LLM models are competing with each other. So one way to find out is this website, LLMstudio.ai, and also Hugging Face leaderboard, which I will send the link after this webinar as well. I'll make sure that we send out an email to all of you, and then all the resources I'll share with you as well. But that's a good way to keep a check on what is the best LLM model. Sometimes it's not always the right idea to go with the best, whatever is the best leaderboards, right? Depending upon your use case, you can decide that. So a good approach that we have found at Lamatic is probably A/B testing LLM models in real time. So whatever you see on the leaderboards is like just single time of event test, right? And it might stand true or not true after that time, right? Because these LLM models, even though they say that the training is done only once a year, but the pre-training and fine-tuning is done rigorously and throughout the time. So even if you have a ChatGPT 4, the ChatGPT 4 that you saw this January and what you have right now could be vastly different, right? So what we do is that we A/B test these LLM models in real time and see like, which one works the best. And based on that, you can decide whether you want to share ChatGPT 3.5 or 4 or another open source model. So you can do all that kind of stuff. Then the second most important thing is the instructions. So fundamentally, instructions or prompts are just the starting parameter of how the prompt should start, and then LLM just sort of completes it. And there is a different fields of prompt engineering, which I'm not gonna get into. It's a completely separate different topic of how you basically inference these LLM models. And again, as I explained before, the one important thing to consider when creating prompts is like the more you can break down prompts into different chain of thoughts, the more accurate it's gonna be. The smaller the smaller area that you give LLM to tackle and give an answer to, the more accurate their response is going to be. So what we often do at Lamatic as well, that we A/B test these prompts as well, what works and what not works. What we have found, for example, if you write 180, then it might not accurately answer. If you write 180, it will answer. So all those things, small things we inference from these LLM models. Sometimes these problems even get fixed and sometimes they don't, right? So based on how much accurate and how much predictable we can get the response of a LLM model, that's what we define as a prompt. Then one important approach is, let's say if you want to train your own custom data, like inherently, if you ask LLM something that is private to your company, it won't be able to answer because it is not trained on that information. So one way that you can train LLM models on your own data, it's not actually training the LLM model, but sort of inference smaller data set of your information before you give an answer. So we call this approach retrieval augmented generation, or RAG. What we really do is that we convert all these images, files that we have available, and we convert them into vectors using some kind of embedding models. And then whenever we have a question, we search through our vector database to find the most closest similar thing, and then give that as a context to ChatGPT or a similar LLM model, and then that's where it finds the information and responds back. Then we can also give it access to some tools. We can give it access to APIs, go search on Bing, you can search on LinkedIn and stuff like that based on what the documentation API is. So you can create specific AI agents for a specific application, and that's where the interaction will be. That's what really compromises of the agents on a very high level. So mix and match of all these things would make your agent. And then finally, you are left up to like deciding how you want to integrate an AI agent. Popular way to integrate an AI agent is just a chatbot, a floating chatbot widget on your website. But this, again, you can see is just for conversational, maybe for support, for inbound leads, or maybe help, but it cannot do much. So one another approach is what we see is embedding, like how GitHub Copilot exists, how you have Microsoft Copilot, like the AI is basically working through your different work suite. So if you have a application, SaaS application, maybe a great idea is to embed that Gen AI into your SaaS in such a way that it becomes part of the software. So if you decide end up doing embedding, so that's what one thing Lamatic really does, is that what we do is that we connect your data sources, sync your data, convert that into all the vectors, do all the heavy chunking, all that I discussed, create significant agent workflows for you specific to your task, use preferred LLM model, either you tell us or we find the best LLM model for you, and then give you a GraphQL API with which you can embed AI into your product. Really simple process, takes no more than 2 weeks, and for general use cases, and it's really reliable and goes off the charts. Now let's see how we can build our own LLM models if we are really getting into that stream. So the first thing, again, this is just a revision of the concept that we have learned from all the principles of how LLM works. The first thing is to break down the problem. Never give an LLM model a simple single prompt and expect it to respond in the same way. Most often it won't respond in the same format. It would hallucinate, and if the data is too long, it might cut off in the middle, and then you have to send a retry. A good approach that we try is that we break down the problem into code using our own custom code, and then break down and send that to different LLMs, and then combine those responses into one single code and then send back to that application. So the result of this is that you have something that is more flexible. You can swap one LLM interaction. It's more cheaper as well, since you are not wasting a lot of tokens. It's more accurate in the responses. It's more performant because it's divide and conquer. So you can run 5 things in parallel instead of running one thing in serial, and it's highly customizable as well. Then we already discussed choosing your own LLM models, what powers these brains of all this operation, which LLM model you are doing underneath. And there are 2 basic consideration to take if you are using RAG as well, is what embedding model you will choose, which is converting your information into vectors, and what query model you will use. This is basically what generates the responses, ChatGPT and things. And we already went through like how you can decide between different LLM models. Then you have to set up your data and ETL. So synchronously, periodically, your data gets into vector databases, creates all these mappings, and then you index into your vector database. So next time, whenever a question is asked or a operation is performed, it goes back to your index database, gets the answer, then goes and boom, does all the responses. So you have to create an autonomous system which automatically does it behind the scenes. Then you have to do all the training and vectorization, which we discussed before. And then finally, once you are ready, you integrate that into your application using API or components. And that is what overall what we are building at Lamatic really does, right? So we have created a no-code tool which helps you connect different data sources, different LLM models, different apps in certain data workflows and agent workflows, making it really simple for you to get from Gen AI, from prototype to production really fast. So now let's see what are a couple of things that you can create with system. So again, what I was discussing earlier is that when we started on this viral cycle, and when I was getting introduced to the concept of LLM, one application we built was Dinnerfy. It is a simple app that helps you figure out what to have for dinner. And the way it works is like we created something called as Recipe GPT. So my screen might not be clear here. So let me try to zoom in. Okay. Let me see if I can make it any better. Awesome. Okay. So what you are seeing really here is that we have a simple no code workflow in which we are using Airtable. And whenever somebody hits upload, we present a form and they can enter the name of the recipe. Now you can just go to ChatGPT and ask it to generate a recipe. But I bet you every time you will ask it to generate a recipe, it would give you a different format in which it will generate the recipe. And this is a very big problem for you, because if you are getting response back in a different format every time, then you can't render a UI for it and you can't provide good user experience. So what we did was that we created a bunch of agents. One agent that you see on the left side of the screen is Midjourney bot. It talks with the Midjourney API and it generates image for the food, which is very real looking. We will see in a couple of seconds. One agent goes and generates recipe tags. One agent goes create the whole instructions. One agent goes and creates the ingredient list and sort of stuff. So what you see over here is that we broke down the problem into multiple small chunks. And then that's how we send the prompts to LLM. Then they respond. We collect the response. And if everything goes well, what you will see over here is that you have the final recipe. Hopefully, yes. Oh, I'm sorry about this peak. But you see, this is whole rendered kind of UI that we developed, but we sort of broke down the problem into different parts, and then we got the response in JSON format from the LLM, and then we can use it to render our own UI. Another place where we are using LLMs right now is in my another organization that I'm working with, contributing with, is 84,000. Is like we are using it to do translation and QA, which is we can translate text from different languages using LLMs, and then we can build a QA chatbot on top of it. So what you're going to see over here is an demo of QA chatbot. So what basically like Tibetan, similar to Bible. So we train all the information that is existing in the Dharma into our vector database. As you can see, that is what we call the loader in this scenario. And on the right-hand side, we create a chatbot interaction, which you will see in a second what it really does. So whenever we ask a question, it goes to that document and the vector database first, finds the answer from there, sends that information to ChatGPT or LLM model that we are using, and then gets an answer from there. So instead of like just directly like asking ChatGPT, we are giving it a context and only respond from that thing. And we can ask really, like we have seen people asking really curious questions, right? Like summarize this thing for me, or how can I deal with this situation? You can also ask very personal and contextual questions. And then you are kind of not giving a bland answer from your ChatGPT, but you are combining your vector database to combine that as well. So that is like one popular approach, how you can use custom data with large language models. Awesome. So that is all about my presentation. That I had a couple of follow-ups for you if you want to get started. LangChain is a popular LLM framework for you to learn how to build your own apps with LLMs. You can use n8n, which is a no-code LangChain integration platform. You can build prototypes app really fast. Autogen is a framework to create your own agents. And then if this was too much to understand, these are the 5 key takeaways that I want you to like take away today. So have an expert loop. The best person to create prompt, believe it or not, is the person who is a domain expert. It's not the engineer, it's not the developer, it's the person who is working day in and day out on the problem. So when at Lamatic we are solving any problem, we talk with the person, we visit them, and we kind of feel the problem with them, and then divide the problem into different prompts. So this is sort of an equalizer as well, and it's sort of an advantage to brick and mortar businesses that were not able to use any technology, because now they can rely on their expert and all the data that they have to create this intelligence system. And that brings us to our second point, that data is everything. The data you train it on, the data you provide in RAG or different assistance model or different fine tuning is what decides the quality of the LLM. Compute is a big factor, but you can't do anything about it because that is definitely out of reach for normal small tier companies. So the best you can do is provide good quality data. But what I also think is like this brings us a very good point in history where everybody has equal opportunity. The barrier to entry is just knowing a good English language. And if you can learn how you can interact with the system, you can build crazy applications. And people have been building all these crazy applications, getting billion-dollar valuations and stuff. So I think it's a great time for everybody to get into the software stream and build their own software using English just as a programming language. Then it's also important to consider safety. You know, when we build this system, it's very important to see that they don't give false information to our customers. And then finally, what impact it generates. A lot of people think that it's going to eat a lot of jobs, like how we were seeing in the initial responses. That's why I asked that question. But what I think, it's just an abstraction of different software cycles we have. For example, we don't see anybody writing assembly level code or doing punch cards anymore, right? So programming language is going to just, be abstracted with English as a programming language, and agents is going to become the next building block of software. If you are really interested, visit our website Lamatic.ai to get a demo of what our platform really does, or sign up on our waitlist, and we are going to make it accessible for everybody, hopefully in next few months. And then you can build your own agent-driven software very easily in no time. That's my time. Really honored to speak with you all, guys. And this is the QR code for the presentation. You have the link also available in the chat. Feel free to use this Miro board for your internal teams to discuss ideas, to learn and revisit this website whenever you want, this Miro board whenever you want, and feel free to ask any questions.
To learn more about our training programs, classes, and what sets us apart, please visit our website at www.computercoach.com.